So we're going to compare our partial quotient strategy to a new strategy called long division. This new strategy of long division, which we will use in our class today, is a really simpler way to do division. And we want to see how this algorithm, so this set of steps for long division really makes sense. So let's start by solving this 3-digit by 1-digit division problem with partial quotients. So with partial quotients, we can identify that we're going to be dividing 724 into groups of 4. So the first thing that I'm going to say is, what multiple of 10, 100, 1,000 can we multiply our divisor by in order to take a little, like a big chunk of this dividend, right? So I'm going to start off with 100. I'm going to start off with 100, and I know that 100 times 4 is 400. So when I put 400 here, I am now going to subtract and have 324. So my dividend now got subtracted 100 groups of 4, right? And we know that division is repeated subtraction, right? Is we're taking groups of our divisor. So we're taking groups of 4 out of 724 until we have nothing left. So that means we want to come up with the number of groups. What is the number of groups that I will get when I cut up or when I divide up my 724 into groups of units of 4? All right, so I'm thinking start off with 100 groups, and that left me with 324 in my dividend. So what number can I use now? I'm thinking that 8 times 4 is 32. So I'm going to use 80. 80 times 4. 80 times 4. So 8 times 4 is 32. So 80 times 4 is 320. And I'm going to subtract. So now I've taken 100 groups and now 80 groups. And I'm going to go ahead and put that in a different color. 80 groups of 4. And I'm going to subtract. So now it seems like I have 4 units left, and I know that how many groups of 4 can I make if I only have 4? Well, 1 group, right? So 4 times 1 is 4. And I am finished. I have no more units to make groups of 4 with. So when my dividend is now 0, or if it's less than my divisor, that means I am done because I don't have enough to make another group of 4. So it seems like I can add these partial quotients. I can add them up, 100 plus 80 plus 1, 181, and that is going to be my final answer. That is going to be my quotient, meaning the number of groups that I can make of 4 in 724. Okay, so if I have 724, I can make 181 groups of 4 units each. So that is my partial quotient strategy. Now I'm going to focus on an algorithm called long division. The algorithm calls for steps, right? Algorithm is just a fancy way of saying steps to follow to solve a mathematical problem. So my algorithm says I'm going to divide, multiply, subtract, and bring down. So the way we do this is by, instead of taking big chunks of 3 digits at one time or 2 digits at one time, I am only going to focus on 1 digit at a time. one digit at a time. So even though the 7 represents 700, I am only going to read it as one digit to make our algorithm easier. So let's make sure we compare it back to partial quotients to check that if it works. So how many groups of 4 can I make if I have 7 units? Well, that's easy. If I have 7 apples, I can make one group of 4 and then I'll have 3 left. So I will definitely have one group of 4, right? And then so I've divided 7 into groups of 4 and that gave me 1. And now I'm going to multiply. My next step is multiply. I'm going to multiply that one group times 4 and I'm going to put it here to figure out now how many I have left. So 7 minus 4 is 3. Right now I'm subtracting. So again, I am dividing 7 into 4 and then I am multiplying what I get, right? I got one group, right? So now I multiply that one group times 4 and I get 4 and I subtract it to get 3. And what we really want to focus here, what we're really doing is we're saying, how many groups of 4 can I make in 700, right? So the algorithm simplifies it to one digit so it's easier for us, but we're really saying that we have 1 here, so that 1 means actually 100. I am saying that I can take that chunk of 400 out of 700, right? And it's exactly what I'm doing here. I am taking 100, right? 100 groups of 4, I am taking it out of 724. So it seems like this is correct. 4 times 1 is 4, and I subtract it, and I have 3. So this 3 really represents 300, right? But to simplify the algorithm, we're just taking it digit by digits. So now my algorithm, after subtraction, it says to bring down the next number. So now I'm going to bring down the 2. And now I'm going to again do my algorithm. My algorithm now says divide again. So I am going to take my 32 and I am going to divide it into groups of 4, right? So 32 units, if I cut up my 32 units into groups of 4, I get 8. So I divided 32 by 4, and now I multiply those groups that I got. 8 times 4 is 32. And now I can subtract because I divided, multiply, subtract. And it seems like 0, 0. It seems like I get 0 from that subtraction. And then bring down. Now it's asking me to bring down the next number. So as I bring down my next number, now again, I'm going to do the algorithm again. You can stop right there and try to start memorizing this algorithm. Divide, multiply, subtract, and bring down. Again, divide, multiply, subtract, and bring down. So we're going to keep doing this until we have no more digits to bring down, to where our dividend can no longer be cut up or grouped into groups of 4. So let's see. Now I brought down my 4 and I am dividing 4. How many groups of 4 can we make from 4? So I'm dividing 4 divided by 4. I know that one group can be made, right? One group can be made of 4 if I only have 4. So now we divided 4 divided by 4. Now we're going to multiply that one group times 4, and that gives us 4. So we divided, multiply, now we subtract. We subtract, and that gives us 0, and then we bring down, and there's really nothing else to bring down. So my problem is over, right? Because my dividend is now 0. I have taken my dividend and already grouped it into groups of 4. So my answer is going to be 181 groups of 4, right? I can check my answer, right? I keep doing this until my dividend is 0 or less than my divisor, and I can check my answer by saying, well, if I have 181 groups of 4, like I think that my answer is, that must mean that if I take 181 of those groups and multiply it by how many is in each group, I am going to get my initial number. So let's see, 4 times 1 is 4. 4 times 8 is 32. 4 times 1 is 4, plus the 3 is 7. So, wow, that does make sense. 724 is my dividend, so that must mean that my 181 is correct. And it does make sense if we kind of root it back to our partial quotients. The 1 is in the hundreds place, right? So it really is representing 100 groups of 4, which is 400. And I have this 4 in the hundreds place to show that. And then my 8 right here, my 8 in my tens place is really representing 80 groups of 4 that represent 320, which are represented here by the 32, which is actually 320, right? And then my last number in my ones place is the 1, and it's representing one group of 4, like my partial quotient is saying. One group of 4 right here. And that is how I finish with my dividend now being 0. So this is correct. My long division algorithm, my long division steps that I can use now really do make sense if I root it down in partial quotients. And this is an easier way, a more sophisticated mathematical tool to solve division. Let's try that today. Solving division with long division by dividing, multiplying, subtracting, and bringing down, which is our algorithm for solving long division.